Okay everyone, so welcome back to lecture once again. Now in this lecture guys, I am going to talk about an optimization. So there are a lot of optimization that we can do. Some of these technique I am going to discuss in this particular lecture, and rest of the technique I am going to mention inside the assignment. So hopefully all of you are going to do it and all of you will be able to learn it, and yeah, you all can implement it in an upcoming future. So let me share my screen and let's start talking about this optimization. Okay, so we have to do some sort of a planning and preparation. So we have to create a database. So here, so create database, MIJDATION optimization. Fine. So this is the database I will be creating, and then use this database. So optimization. So just go ahead and use this database. Simple. And inside this database, I'll be creating a table, by the way. So let's create a table called as department over here. A table called as department, a simple table with ID and name. And then let's try to insert some sort of a data with respect to ID and name. So inserted a data. And then let's try to create a table called as employee table. Yeah. So let's try to call a table called as employee table over here. And here, so yeah, so employee table, so where we have like a ID, we have a name, we have a department ID, and then we have a salary, we have a date of joining, and we have a foreign key, which is referring to a ID of department table, this particular table. And I think these are not a new operation for us, so we have done a lot. It's failing somewhere. Okay, use optimization, then create a department, then insert a record once again. I think I haven't selected a database, and then let's try to create a employee table. Okay, fine. All these tables creations are done. Now, so once this part is done, table creation is done. So maybe we can try to insert some sort of a record inside my employee table. So let's try to insert a name and then department ID and then salary and date of joining, and ID is anyhow it's an auto increment. So automatically it will try to do the work. Fine. So here we have two tables. One is an employee table and one is a department table. Employee and department tables are basically connected. Now let's see, so how we can try to optimize a query, and what are the way by which I can optimize the query. So the very first way which I would like to discuss over here is indexing, and I have already discussed about indexing in my index class as well. So if I have to create an index, so I can try to write create index index, and then I can try to give an index name, so maybe idx, and dept department dept underscore id. Now on which table? So employee table, employees table with department dept id. So I'm just trying to create the indexes on a department id, so that department wise it will be able to keep the segregation. It will be able to keep the segregation, so that whenever I'm going to fire a query like select star from employees, emplo employees. So whenever I'm firing this query where dpt underscore id is equals to 1. Yeah, dpt id is equals to 1. So let's suppose I am going to fire this query. So it will be able to give me all the record. That's pretty much obvious, and there is nothing new that we have done. But what I wanted to show you over here is that click on this execution plan. And now here, if you will look into the execution plan, you will be able to find out that it is trying to fetch 4 records. It is trying to take a help of idx department id. Means it is not doing a full scan. It is trying to take a help of this department ID. I have given department ID is equal to 1. So it is only looking into the indexes with the department ID is equals to 1. As simple as that. Yeah, as simple as that. So this is one of the optimization, right? So non-unique key lookup, and this is one of the optimization that we are able to perform. Another kind of optimization, so generally what we do, so we try to perform like a select star. This is index is one of the operations. So select star from employees, right? We try to do this, and here, so what it will do, it will try to fetch all the record. It will try to fetch all the record. Let's suppose I have a millions of records, employees. So let's suppose I have a millions of records. Now in that case, it will take some time to perform all the read operation, because read is going to be the heavy operation. So whenever you are looking for some sort of a record, you should not write like a select star from the complete table. I can try to limit it. So I can say limit 5, so that it will not try to read all the record. It will try to read only 5 record, 10 record or 50 record, because in case of millions of columns, it is, millions of records, it is going to give you the issue. Same goes for column. So here we are writing select star. Instead of doing that, we can try to even write maybe a select name and maybe a salary. Yeah. Select name and salary. And I think this is much more optimized as compared to writing select a star from everything. Yeah. So this is again another way of optimizing a query. Now, so there is something called as covering indexes. Yeah, there is something called as covering indexes. Let's try to talk about that. So covering indexes means I'm trying to take 2 columns and then I'm trying to create an indexes on top of that one. So here, let's suppose I have a name and salary, and I can try to create an indexes even on that, which is called as technical term covering indexes. So create CREAT, create INDEX index, IDX, and then index name and salary. For this, I'm going to create the indexes from, on what? Employees. Yeah. So on employees. And here, so name and salary. So name and salary. So it is going to consider to create that combination. It is going to consider to create the indexes. Okay, let's do it. So here index creation is done. Now, if I'm going to fire like a select name salary from employees, where name like, right? So just try to match this one and then give me the record. Now let's see, let's suppose if I'm trying to like execute this one, I will be able to get 1 record, but that is not important. Important is this one. So here it is trying to do a index range scan, and based on the index range scan, it is trying to give me the final output. Yeah, it is trying to give me the final output. So it is not going ahead with the full table scan. Wherever it will go with the full table scan, that will be a most costliest operation. So I'm just trying to show you that, okay, maybe with the help of this, I'm trying to prevent it. Yeah, I'm trying to prevent it. Similarly, so if I'm going to like take select star from employees, right? So inside this employees, we have a date of joining. So maybe year wise, we can try to perform the indexing operation. How? Year wise indexing operation I can try to perform. So before that, I would like to show you something. So here I have written select star from employees, where year date of join is equals to 2020. Now execute it. Now just go ahead and look into the execution plan. So it is trying to do a full table scan. Now this is one of the costliest operation it will end up doing. Yeah. So it is one of the costliest operation because it is going ahead with the full table scan. How we can try to reduce it? So maybe we can try to reduce it by creating create INDEX, create index, right? So IDX and then DOJ, right? DOJ on EMPLOYEES employees table, on employees table basically. So where I'm going to extract year from date of joining. So I'm not going to do the indexing on date of joining. I'm going to do it on a year. So DOJ column, I'm trying to extract a year out of it, and then on top of this I will try to build the indexes. Simple, right? I'll try to build the indexes. Now build the indexes. Index is done. Now let's try to execute this part. Yeah. Now let's go and check. Same thing. I have same query I'm executing, right? Now go and check. So here this time it is not looking into all the record. It is looking into what? It is taking a help of DOJ index which I have created, and it is just trying to look into 4 records. So this is optimized one. The previous one without indexes was not the optimized one. So this is a way by which you will be able to do this entire things. Now there is something called as explain. There is a command called as explain. I have already used it in my past, EXPLAIN, explain, and any kind of a query you can try to give. So it is going to give you the explanation that what it is going to do. So which index it is going to look into, or what kind of optimization it is going to perform, each and everything it is going to give you. This is what like explain does. For any kind of a query, it is going to give you the explanation. Okay, that's again cool. Now, so let's try to perform some sort of a join operation. So we have already seen the join operation. So here I'm trying to perform a join operation, and I'm trying to perform join operation on a department ID from employee table and ID from a department table already created. And this kind of a join we have already done. I'm writing a filter condition over here, right? So just try to fetch me a data. So where like a salary is greater than 60,000. First of all, let's try to do this. Only execute this part. Yeah. Don't execute the where part. Now here, so I'm able to get the data. I'm able to get all the records. Execution plan wise. So yeah, full table scan, 10 row. And then from here, so it is trying to like get a department table. And then finally it is trying to do a nested loop. And then it is trying to give me the final record. Now here, again, if I'm going to attach my where clause, right? If I'm going to attach my where clause, you will be able to find out the exact same thing, right? Full table scan. It is going ahead with a full table scan, and then it is trying to, do a lookup into your department table, and then it is one by one, one by one, one by one. It is trying to attach. Yeah. So it is trying to attach, and eventually I'm able to get the final data set. So data set, so name and department. So the department which join operation which I'm trying to perform over here. Yeah. So here I have applied a salary filter, right? So when I have applied a salary filter over here, so it will try to reduce a row on an early stage. It will always try to reduce a row on an early stage. So again, this is where just by applying a where clause over here, I'm trying to optimize the query. So I'm not looking for everything, just try to look for only this much of things, and rest of the thing is completely fine. I'm not looking for anything else over here. Now there is another way of doing or achieving optimization called as partition. Partition also I have discussed while I was discussing the indexing. So partition is nothing but it is going to create a physical like a file basically. So here I'm trying to like create a partition based on year, date of range, and I'm just trying to like create a multiple files. So alternate employees and create a partition. So foreign key are not supported in conjunction with partition. Okay, so that's a problem. Foreign keys are not supported in a conjunction with partition. So I have to drop my foreign key, by the way. So just a minute, guys, we are going to fix it. Okay, so let's drop the foreign key. So here I can try to write, because in MySQL 8 plus it is not allowed. So they have deprecated it. So here alter table, and alter table basically employees. So alter table employees basically, and drop foreign key, and my foreign key was DPT underscore ID. Yeah. So let's drop it. Can't drop DPT ID. Check the column key. Okay, sorry. I think it's a DPT, not ID, right? So ID from the department column. So to get the foreign key, I can try to write show create table, so that it can give me a foreign key reference, which I can delete. So create table employees, emp hello YEES employees. Fine. So create table, and here, so it is trying to show me primary key, this constraint, this one, foreign key, department ID. So this was the constraint. So employee IBFK underscore 1. So this was the foreign key constraint which it has created. I have to copy it. Yeah, so my foreign key name was this. So I have to delete this one. Fine. So foreign key ID, this one. So let's try to delete it. Okay, deleted successfully. Now I can try to call a partition. Still a primary key must include all the column in the table. Partitioning. Okay, let me check that as well. Okay, so simple solution is let's drop the table. I think that will be much better. So drop table employee, EMPLOYEES, employees. And I'll try to create it. Because of this key, it is giving me an issue. So I'll just try to call drop table employees and unknown table optimization dot employee. Okay. There is a table EMPLOYEES, EMPLOYEES. Okay, great. So we have dropped the table. Now let's try to create a table from the scratch. And while creating a table itself, I'm going to define the partition. That okay. So this, and primary key is ID and date of joining, and then I'm trying to create a partition. So whenever I'm going to insert a record, it will end up inserting a record based on the partition. Very simple. So it will end up inserting the record based on the partition. So for example, if I'm going to insert a record, let's suppose I'm inserting this record. Yeah, once again. So it will try to use a partition and then it will start inserting a record. So it has inserted this 10 records inside this one. Okay. Now I can try to perform some sort of a operations. Maybe I can try to say that try to give me a record between this date to this date. Now let's try to execute this one, because based on this I have done the partition. Now you will come and check. If you are going to come and check, so it is trying to do a full table scan. It is showing me full table scan, but still it is trying to look into 4 records, 4 rows. The only reason is that it is looking into only that portion of the table which is holding a record based on 2020 partition. Yeah, 2020 partition. So again, in this way, I'm able to optimize it. So indexing is one of the way, limit is one of the way, partitioning is one of the way by which you will be able to optimize your query. There is something called as catching. So you can try to do a catching as well. You can try to come with the efficient join operation. So there are multiple ways by which you all will be able to optimize your entire query. And obviously that comes from the experience, right? So more like optimization you will work upon, more like a query you will write, you will be able to get you will get efficient in terms of writing a full scale optimized query. So with that, thank you so much everyone. Take care and see you again in my next lecture.